Namaste. I am Rohan Ranjakar, and in this video we will learn about interpreting the regression coefficients. Here's the OLS regression, and we will deal with three models: LogLog model, LogLinear model, and LinearLog model. So now let's begin. We will begin with LogLog model or LogLog regression. Regression is a unidirectional relationship between two variables, but not a causal. Consider a simple log-log model, that is ln y equals to alpha plus beta ln x. It is called log-log because we have because we have log in the left hand side and log in the right hand side, so it is log-log. So now let's view its differentiation so that we can interpret this beta coefficient more efficiently. If I take the derivative of this whole equation, then I will get as dx ln x delta by delta over delta x bracket this right hand side equation, and I will use the chain rule in the left hand side, and I will get the result as below, and I will get the result as below for the right hand side because alpha and e will get a derivative of 0 with respect to x, so they will get cancelled out, and the beta will come out as it is constant. So as we know that the derivative of d by dy ln y is 1 by y, so we will get 1 by y and its bracket dy by dx. Similarly for d by dx ln x, it's 1 by x and the beta is left over. And if I cross multiply the delta x in the both side, then I will get the resulting as dy by y equals to beta dx by x, and this is simply the percent change in y equals to beta percent change x. And you may confuse that why it is percent change, why I have written it. It may be called as change in y over y, and it may also be called as yt plus 1 minus yt divided by yt. And here this change is change in yt, and this yt is simply y. So what is this? This means it is a growth or it is change, and if we multiply it by 100, then it will be percentage change. So I have written percentage change. So if we interpret, we interpret as 1% change in x brings beta percent change in y. So now heading towards log linear. It is called log linear because we have log in y and it's linear in x, no log in the right hand side. So we will continue the similar steps and we will change rule here. Simply it will be 1 by y, and it's a change in y, but it's simply change in x. So we need to interpret as then 1% change in x brings beta hat times 100% change in y. It means that this is not in the percent form, but we need the value in the percentage. So we must multiply beta hat by 100 because we need the value of or we need to predict the value of y in percentage, so we must multiply it by 100. So for log linear regression, in the log linear regression it is simply called linear log because it's linear in y and log in x. And if I continue this step, then I will have change in y in right hand side but percentage change in x. This means that we interpret it as then 1 change in x brings beta by 100% change in y, because the beta is already in percentage, but we don't need, or we don't need uh, the percentage change of y. We need only unit change. So we will divide the percentage of beta divided by 100. So now let's move towards the practical in our stata. So I have already opened the stata, and here are the three, and here are the data of sales and advertisement, and you can have look over it. The data of sales and advertisement are in this section, and here is advertisement, it's in $1,000,000, sales it's in $1,000,000, and log sales it in log of sales, log of advertisement. So now let's have a glance over. So now if we need to perform log regression. Then we will simply hit reg ln sales ln advertise, and we will hit enter, then the value. And now in this case we are only concerned with the interpretation of these values. We are not concerned with the above values, that's r square or something. We will ignore it for it now. So now in this case we will interpret it as 1% change in advertisement brings about 0.21% change in sales revenue. This means that if we change, or if we increase the revenue, advertisement revenue by, this means that, let's increase its size. This means that 1% change in advertisement expenses leads to 0.21% change in sales revenue. And this is the simple interpretation of the LogLog regression model. And now let's erase it for now. And now if we run the LogLinear model regression, they will take log in the sales, but we will not take log in the advertisement. Then what must be our interpretation? Our regression is log linear regression. It means that the coefficient of the advertisement is not in percentage. This is not in percentage form. Sorry, this is not in percentage form. This is not in percentage form, and we must change it to the percentage. It means that 1 unit change in, or let's say it that if advertisement expenses increases by $1 million, then sales revenue increases by 0.14%. This means that simply it's 0.0014 times 100. It's times 100. It's and and this is the interpretation of our regression coefficient. And now we will head towards the final, that is regression of linear log. This is the regression of linear log regression. And how to interpret it? It's simple. We will first need to identify that this value is actually the percentage change, and we don't need percentage, we need unit. So we will divide it by 100. So in this case, if advertisement expenses increases by 1%, then sales revenue increases by 1.18 million dollar. The interpretation is, if the advertiser expenses increases by 1%, then the sales revenue increases by 1.18 million. So this is the interpretation we have finally derived for our three models. And in this recap, we can also have a glance. That is in the case of LogLinear model, it's that we interpret as 1% change in x brings beta by 100% change in y, and for the LogLinear model it's just opposite, and for the LogLog model it's both percentage change. Thank you.